In this video, we're going to explore deeper into transformations. We'll start by exploring how to apply a sequence of transformations, and then we'll look at how we can create our own transformations to answer some of the more specific application style questions. If you haven't yet been introduced to the fundamentals of transformations, that's okay. I have a video covering that exact topic. Just click the link above. Otherwise, if you're already familiar, let's dive into it. In your exam, you might be asked to apply a series of transformations. The process of doing this is pretty much the same as if you were to apply only a single transformation, except we're going to repeat that step over and over again until we go through the entire list top to bottom. The key factor here is that the order matters. We can explore this concept by going through two examples which use the exact same transformations, but they're in a different order. First, we have a dilation factor of 3 from the x-axis. That means it applies to the y values since it's going away from the x-axis. Next, we have a reflection in the x-axis. This means that the x-axis acts like a mirror, hence the x values are going to stay the same and the y values are going to change. Finally, we have a translation of 5 units to the right and 1 unit up. Now that we've gone through the full list of transformations, we can rearrange for x and y, and then substitute that rearrangement back into y equals f of x, and finally, rearrange to get y back on its own. Now that we've gone through this example, let's see what happens when we switch that order. In this example, the translations happen first. So we start by translating 5 units to the right and 1 unit up. Next, we have a reflection in the x-axis. And finally, we have our dilation factor of 3 from the x-axis. Again, we're going to rearrange in terms of x and y, and then substitute that back into y equals f of x. Well, isn't that interesting? Even though both examples had the exact same transformations, we got a very different result depending on what order they were in. This issue only occurs because there were translations in our transformation list. If you only have dilations and reflections, it doesn't matter what order you put them in, you'll still arrive at the exact same spot. But when you have translations, you're actually adding a new term to the x or the y. So when you do that, any further dilations or reflections have to apply not just to the x or y, but also to that translation term. If you apply the translation first, then the dilation and reflection need to apply to both terms. If you apply the translation last, then the dilation and reflection only apply to the x or y. Now, this usually isn't an issue when you're just following a list of transformations, but usually in the exam you'll have to create your own transformations, and this can get a bit tricky. So next, we're going to cover how to handle this. This example came from the 2023 Tech Active exam, and we can use this process to solve not just this question, but many questions like it. We start by identifying the original function and the new function. In the question, we're told we're going from f to g, so f of x will be the original function and g of x will be the new function. From here on out, g of x is going to use x prime and y prime. This is because g of x is the new function, and this just makes it easier to keep track of things. Next, we're going to rearrange both functions until all the transformation factors affecting the y are on the left-hand side, and all the transformation factors affecting x are on the right-hand side. F of x has no transformation factors, but g of x does. All we have to do here is move the dilation factor of a half over to the left-hand side because that affects the y, not the x. Now that we've done our rearrangement, we can express this as a transformation by equating the x and y components. Starting with the x components, we can see that f of x just has x, whereas g of x has 2 minus x prime. So we'll equate those two together. Similarly, by looking at the y components, we can see that f of x just has y, whereas g of x has 2y prime. So we'll equate those as well. All we need to do from here is rearrange to get x prime and y prime on their own. From here, there are a couple different ways you could go about this. This is because there's more than one list of transformations that gets you to the exact same spot. We saw this earlier when it came to looking at the order of dilations and reflections. It didn't matter what order you had those in, just as long as they happened. So if you get a different answer by using your own process, that's totally valid. This is just the easiest way that I know to solve these types of questions because the process is repeatable. You just go step by step by step by step and you get to the right answer. The first thing we did to make life easier was back in step 2 when we separated the x from the y. We do this to make it clear that transformations to the x are completely independent from transformations to the y. You could write all the x transformations and then all the y transformations, or you could flip the order and do all the y transformations, then the x transformations. You could even intermingle them if you wanted, as long as you kept the order of the x and y consistent, but don't do that, just for your own sake. Now that we know we can do the x and the y independently, we just need to know what order we can do the x in and what order we can do the y in. And the easiest way I know to do that is to rearrange both expressions to get the coefficients off of the x and y. The y side already has done this, there's no way to simplify this further, but we can do this with the x. Now, if you want, you can write this out as a transformation sequence like I've listed in the steps, but this isn't strictly required. You can just look at the equations if you like. Either way, we can now write out the sequence of transformations by unwinding the brackets from the inside out. All this means is that we're going to write the translations first, then the reflections, then the dilations. The y dilation was already written in the first slot, so all we have to do is write out our x components below that. As I said before, there are many different solutions to this, so if you did this exam and got a different result, don't panic, your result could have been correct. This is just the process I use to keep things as simple as possible, just step by step by step, and then you get to the end.